Alright, here's an issue that will affect the way some people will write mechanisms, and it's something to certainly think about as far as how the chemistry actually occurs, is if I say that we have an alkene reacting with hydrochloric acid, HCl, then the HCl is usually added aqueous. And so I can write a mechanism saying that the electrons in the alkene are going to go pluck the H plus off of the HCl, and that's essentially consistent with what happens. The H plus, its original source was the HCl, is going to end up on the alkene. But if you remember from general chemistry and from other things, if you have hydrochloric acid and it's dissolved in water, then that's going to dissociate. So if you have a solution of aqueous HCl and it dissociates into H plus and Cl minus, then you're really not going to have any HCl to react with. You'll be reacting with the H plus sort of all by itself. But again, that's not exactly the best way to write it either, because a barren H plus has an empty orbital and acts as an acid and accepts a lone pair from whatever might be available that has a decent lone pair. So when there's H pluses around and there's water around, what you end up having is the reaction between HCl, which pure is a gas. So if you had HCl gas and you bubbled it into water liquid, then that would very vigorously dissociate. And since trying to write it sort of like a mechanism, the lone pair on the oxygen would go grab the H plus off of the HCl, and then you'd end up with the H3O plus. So whenever you have a strong acid in water, what's really present is the H3O plus, and that's what will act as a strong acid in the reaction. And then the other thing that would be present is the counterion of the strong acid. The conjugate base of the strong acid would also be there. So a lot of times you'll see people write mechanisms where they have sulfuric acid or hydrochloric acid reacting in the mechanism like this. And it's not the perfect way to do it, because in an aqueous solution, you're not really going to have much undissociated HCl. What'll really be happening is the H3O plus will react with the substrate. So we could have the alkene plus H3O plus, and when that reacts, again, you have the acidic H plus, which the pi bond on the alkene will go get the H plus and protonate, and that will leave the hydrogen on essentially a carbocation. So that's the way a lot of these reactions will actually go. And when I write mechanisms, sometimes I have the undissociated acid as the source of the H plus and have it react directly like this, although knowing full well that in solution we don't really have that. Some people get really caught up in the semantics between an H plus, which looks barren and that's unstable, but if it says H plus aqueous, then it's an H plus associated with water molecules. It's essentially the exact thing as H3O plus, aqueous. And in reality, an H plus gets surrounded by about 5 water molecules. So some people would really write this as H2O 5 plus to try to show what the primary thing in solution is. That, of course, gets very complicated. So when I write mechanisms, I'm going to either write the undissociated acid involved in the mechanism, knowing that that's not the major species in solution, it's just the original source of the acid, or I might write the thing that is predominantly in solution, the H3O plus, reacting with the substrate or the other reactant to get to an intermediate or something else. So when you have strong acids in water, there's a couple of different ways you'll see the mechanisms written, And some are better than others, and some are easier to deal with than others. So that's something I figured I'd talk about a little bit, that H plus is essentially the same thing as H3O plus if the aqueous designation is there. Reacting directly with the acid is a little fictitious because the undissociated acid is not really present in any strong quantities, and it might be better whenever we have a strong acid to write the H3O plus reacting, knowing that's really what we have in solution when the H pluses that dissociate find waters and turn into H3O pluses. So that's something certainly worth thinking about for sure.